Welcome again. Thanks for attending this invitation. We will start now the technical and hands-on introduction to the S2S4E decision support tool, which is a European funded project in the Horizon 2020 program. So the agenda of this webinar, we'll have 5 sections. At the beginning, I will do an introduction and an overview of the project. Following, we will show a guided tour of the decision support tool. Then later, we will dig on a little bit more on the technology behind through a technical explanation of the tool. And finally, we will open a Q&A session, which you can already send your questions during the presentation through the webinar application. And at the end, we will do a wrap up and comment some information for the next webinars. Important, the speakers. As you can see, myself, my name is Joan Miquel Anglès. I'm Commercial Director at Energix. I will be introducing the webinar. Llorenç Lledó and Andrea Manrique from the BSc. They are 2 researchers that are behind the scenes on the DST, on the sub-seasonal to seasonal forecasting tool. And they will explain the more indeed the technical details of the technology and science behind. And also Isadora from the BSc, communication specialist, but he has been really involved in the design of the tool and the interface and the user interaction. So they will lead the guided tour of the DST. So I will go in the introduction. This project S2S4E is the acronym of sub-seasonal to seasonal for energy, which are climate predictions applied to the energy sector. So the project motivation is to provide more interpretation and provide an application that can benefit from the technology of the climate sub-seasonal and seasonal forecast. So as probably the audience already know, the short-term forecasts are widely used in the energy sector for many players, but using the sub-seasonal and seasonal forecasts, which increase the horizon, the time horizon of the forecast, are not yet well introduced because some barriers, some difficulties to interpret and to integrate this information in the decision-making process. So this is the main motivation of this project, to provide technology through a decision support tool, which will enhance and help the decision makers introducing information of these climate predictions. The current status of the project is right now it's a 3-year project, but we are in the midline of the project, so it's more 1 year and a half. It's been running the project, and right now, but we are proud to launch already a beta version. And the main goal is to provide to keep going, and during the next year overpass the beta version and to produce an output that finally will be a more stable output. So who's supporting the project? The main 5 research centers, which led by the Barcelona Supercomputing Center, based in Barcelona, Spain. This is the leading partner of the project, and is supported by another 4 research centers. The project is also oriented to a final users that are actively participating in the project and in the design of the DST tool, and also 4 industrial partners which are contributing to produce the technology. please consider that it's yet the decision to support tool that we are going to introduce today. It's still a beta version. It is planned yet in the short term some major update, but consider that it's yet even it's a lot of work behind already, and a lot of a lot of work on that. So it's yet a beta version, so it can be some restriction on the daily use of the decision support tool. And right now I will introduce Isadora, which will provide the guided tour of the S2S for DSC.
Thank you very much, John Miguel. Now I'm going to open the tool and everything. Just give me a few seconds to connect everything, and then we will start the hands-on session. Okay, so here we are. Now what you're seeing is the browser. Basically, the DST is an online tool. It's available through any web browser. It should be also somehow possible to access it through iPad, other smart devices, but also the functionality available changes a bit according to the size of the screen. The best way to find the DST is just to remember the acronym of the project, S2S4E, and this is the web page of the project. And here you will find all the information on the project, the scientific research. This is our research and innovation, so you will also find information about the research part and the innovation. There is the section about climate services, and here you will find other information that we can comment at the end of the webinar, but particularly the link to the decision support tool. Once you go to the decision support tool, you will see a landing page. I think in the reminders for the webinar, you should have got the information about registering yourself. So here you can either access if you already have a login or register for the first time. It is free and available for everybody, at least during this operational phase funded by the European Commission. After it, we are still working in the project about which is the business model and which will be the functionalities, if there's any that will still open and which ones will become a product, a commercial product. As Joami was saying, this is a beta version, and of course, once you enter, we will be commenting, because during these next 14 months, we will be making updates in the interface, making improvements according to your feedback and also for the feedback in the project. If you go, I'm not gonna do the register login because I'm already there inside, and because of performance and because there are many registered users for this webinar, which is good for us, but also might lead to some performance issues, I have tried to make it a bit easier. So once you log in to the DST, this is the main interface that you will find. The interface itself, it has 4 main elements. There's an initial and main element, which is the upper bar, where there are different basic functionalities that I will explain later. There is a settings panel in the left, which is for making more advanced filtering in the map and decisions. There is the map, which is, of course, the main part for the visualization, and a detailed panel that may open or not according when we click on it. So just to start, basically, there is basic functionality about searching for place, for coordinates, or just moving around the map. Then by default, we're going to skip now this for now. By default, it's providing the last prediction. And then here we have the forecast window. Basically, subseasonal to seasonal predictions, one of the aim of the project was to show somehow both types of forecasts. So in the arrow first, you have available the forecast for the subseasonal range. So this is for the coming week, in 2 weeks, 3 weeks, 4 weeks. After that, we have the seasonal forecast. So this forecast was issued, was available in the DST the 17th of September, which means that the first month forecasted was October. So basically, this is the forecast for October. This is the forecast for November. And this is the forecast for December. One of the things, just to highlight, and you will always see in the DSP here, which is the beta version that you are interacting with. Right now we have beta version 1. In a couple of weeks, there's going to be an improvement just to handle with the data performance in the database behind. This is huge big data, and it takes time. So now we have some response times that we want to be improving. This is something that will change in beta version 2. Also, some of the information displayed right now here. So in case we select the seasonal forecast, that it was for October at that time, or we can say for November, so we see a next forecast. In the next version, we will have the information of the forecast window, when is the valid time for this forecast. Right now, will only be able to see it if you click in one of the places. So in this case, it would be the forecast for the 1st to the 30th of November. But in the next version, it will be available and more clearly signed on it. Once we are in the visualization and we choose the forecast time or the forecast window that we want to see the forecast for, there are a number of decisions that we can make. First, for sure, I mean, here have I already decided to show temperature aggregated by country. But there are a number of other categories and a number of other variables. Most of the essential climate variables, they are shown either by aggregated by country or gridded information. But right now, for making it more simple, I'm going to start with aggregated by country, explaining a bit about the visualization. So if we take, for example, Poland, we take one of these examples. The first more obvious thing we have is that we have 4 different colors. We have orange, we have blue, we have dark gray, and light gray. Basically, this is to show probabilistic forecast, and then my colleagues, Llorenç and Andrea, will go deeper into explanations. But basically, we are showing the forecast and which is the most likely category. In this case, there is 61% probabilities of having the temperature for the whole country being above the average. Below, sorry. Also, you may notice here some dots. While preparing this interface, we have gone a lot of user interaction with different experts. And one of the things that we wanted to work, or we were requested, was a way to signal when there is high probabilities accumulated in one particular category. So basically, if we go to the left panel, you will see a number of filtering options. First, there is this option for view all. Basically, here you will see the forecast for each of the countries in Europe, no matter which one. But not all of them has good skill. Not all of them are better than just checking past predictions. And that's why you have the possibility to either see what the forecast is saying, regardless of the quality, or just make an initial filter where you only see information for those countries where the forecast is better than climatology. Also, this filtering option can get dynamical, so you can be more strict in the level of skill you want. So you will only see forecasts in places with a skill above the level that you use. Also, for your information, there is a kind of a scale that gives you an idea of how better it is, this skill. Of course, if we get 100%, it would be perfect forecast, doesn't exist. So we won't see anything in the map. So by default, our recommendation is to leave it with the skill, with the minimum skill. But it's up to any user to be able to see all the forecasts. The other feature that was important for the users helping us to reproduce the tool was to set a probability threshold. Right now, the probability threshold is 50. This means that for those countries where the most likely category is above 50, they are signaled special, they are highlighted. This way, you can really spot places where you have a higher probability. Instead of 50, we could set 60%, and then you will see that there are some countries that there is not this highlight. Again, for us to trigger a decision, we want to be very exigent with probabilities and we put 80%, then there will be no feature in this case in particular highlighted. Of course, this will depend on the moment of the year, the variable that you're choosing and you're working with. Then you might set this threshold to the level that is better for you. This is the average way of working, but well, we could, I suppose you would like to see also how it's readed information. I could also do it here. Let's gonna try, because it is live and we are a lot of people connected, so probably it can take some time. So I leave it like this. I hope it will, yeah, perfect. So basically, now we're seeing the same forecast, temperature, but instead of aggregated by country, we see it gridded information. Here again, you could see the forecast everywhere, but then with no filter for the quality of the forecast. Then, yeah, it always takes some time, but you will see everything. You will be able to go in. Then we're gonna make the filter again. Here, what we have is the probability threshold. It is signed with two different type of sizes in the glyph in these balls that are shown in the picture. So when the forecasted category, the most likely category is above 50, the balls are shown bigger. So if we click here, then we will see here the probability is 53. Then if we go for 70%, it might happen that we have nothing, but let's see. So we'll see across Europe right now we only have this point where we have 73% probabilities with good scale. Right now for this last forecast, if we move, I just go to another tab and I move to United States, you will also see that there are different regions with low probability, high probability. And one of the things, additional things that we want to highlight is once you are in gridded information, you also have another filtering option, which is the option for showing extremes. Once you click on the extremes, what you see is a triangle that it can be orange up or blue down in the places where the probability of being in the P, in this case, in below the P10, it is a probability larger than at 10%, which could be the standard expected probability. So in this case, if we look into the detailed panel for this position or for this one, you will see that there is a 55% probability of falling in the below the P10, the 10th percentile. And in this case also it's always worth checking the skill of the forecast. Right now we are showing the triangles regardless of the skill. This is a functionality that we are waiting for feedback because we can just show the extremes when there's a skill, but this is something that we don't want to decide ourselves. In this case, the skill is high. So basically in this region, or at least for this point, there is 55% probability of being below P10. Once we see this is the basic information that we can find. So we can have information on the skills, the forecasted probabilities, but then we can open it up and we have extended information. The summary part is equal at the simple detailed panel, but then here you can also see the forecast trends. This is basically the possibility of seeing the forecast for each of the 4 subseasonal weeks and the 3 seasonal months, and then see which is the probabilities. So basically you see for these months, the probability is quite high. For the next one in November, there is not skill enough. So we show the forecast, but we really sign on as such. And for December, the probabilities get much more equal. Here, this is a functionality that it is not yet ready for all the forecasts, but it will be. Here you will be able to see the past observations basically using reanalysis. So for this particular October, for all the 30 last Octobers, you will see which was the forecast in hindcast mode, and you will also see which was the observed value according to reanalysis. So this is the basic way of functioning of the tool. There are other functionalities like changing to dark map, particularly for those people who really wanted to spot the places with color, what is going. And there is a common functionality for adding installed wind power, so for solar, for wind, and for just having a better situation of if this low wind is falling in a place where there are wind farms, for example. At any moment in the DST, especially the first time that you sign in, you will get it automatically pop up, but you can always click on the guided tour. This is a basic explanation, similar to what I'm doing now, but you will see a bit what is coming on, what each of them means, and a bit of the explanation of the tool. And there's another functionality, well, advanced information. This will give you to a page, just one page with much more details on the technical side. We have tried to be exhaustive, but of course, this documentation will be changing according to the questions that we get. If there's any question that is not clear in this advanced information or that should be added, we will be working. So this is a kind of live page for this. Finally, this is the download data. Unfortunately, we launched in only 18 months of a project. This is massive amount of work, and downloading data at the end, we had to keep it as a non-active functionality yet. That has to be implemented. Basically, there is a number of challenges for making this functionality active. First, the different types of users, so different needs of different information. Some people is in need of punctual information, just getting one coordinate and get the forecast for coordinates. Other people want to download the global forecast. And other people, they may want to have this information in NetCDF, and we have got some requested that NetCDF is not the proper format, that they would need comma-separated value, for example. This case, I mean, we know download data is one of the most requested functionalities for any advanced user in energy, and we are quite willing to hear which is your particular view on this. So feel free at any moment to contact us in the S2S4E project. You will have the contact details also in this webinar. This will be posted online, so you will be able to give us your feedback. We envision to have this functionality, at least a part of this functionality, active before the end of the project. We really would like to, but we really need to analyze which is the best format, because it's even for the performance issues for this DST, there's a lot of information, much more than we always are used to. So it is not trivial to share this big amount of data. This is the overall perspective. Once you sign in, then you will also see that you have your profile options. So here you see my profile. You can change your password, and you can change some of your preferences. One of the options is to subscribe to newsletter. Basically, this is important if you are interested in the tool, but there are some features that are not yet there, because through these newsletters, we will be telling you when there is a new version of the beta tool. Then also you can subscribe to the forecast outlooks. This is a PDF version of the outlooks that you can download with all the variables. And you can also subscribe to webinars, so you get all the notification for the webinars. Also here, this authorization key, we cannot explain it yet, but basically this is related to work on having an API related to this tool. So as we foresee the tool, and we know that in-house teams that have capabilities to deal with this data could be interested in making API calls to the DST in order to get the data, but bypassing the online tool. This will be available at some point, but it is not yet there. So here we are. So I think we can go, if you have some particular questions, they will be telling me, and then I will be answering. Hi. So one of the questions is if the forecast window is based on the current date or the time from the latest forecast. It is based in the time for the latest forecast, no? for the start date, basically. So what you're seeing here, this was issued in, for example, this is seasonal. It was issued the 1st of September at ECMWF, and then it was available in the DST around the 17th of September. So this is what we are seeing.
There is another question, Isadora, about the API. What type of API will be implemented? REST or others?
I'm sorry, I really cannot answer this. I really don't know. I mean, for this part of the API implementation, Capgemini, this big consultancy firm, they are having quite involved. But what I can say is we can ask the technical people. So after the webinar, we can also be answering some of these questions if they remain unsolved.
There's another question, which is, could you explain the use of skill level and probability threshold? This question will be solved in the following section with Andrea and Llorenç. Thank you very much, Isadora, for your presentation. It's difficult to resume and summarize all this information in 20 minutes. A lot of work and discussions behind this tool. There's other questions regarding the DST, but let Andrea and Llorenç explain the section, the technical explanation, and probably some of the questions will be solved. Otherwise, at the end of the webinar, we will reread again the questions. So please, you can start.
Okay, thank you. So we're going to go now through an introduction and some explanation about sub-seasonal and seasonal predictions and the data and post-processing that's behind the tool. So I'll explain, just to put in context, what type of predictions we're looking at here. Here we have a timeline, and on the left-hand side of the graph, we have weather forecast, which is what most of us are familiar with, which are predictions for the next hours or even 10 or 15 days. This is what's called also medium range. This type of forecasts are very conditioned by the initial conditions of the atmosphere or the system. So this is the temperature or the cloud cover or what conditions we have right now affect very much what's going to happen in the next days. But then after some time, this information is lost, and we reach some time ranges where we use what we call climate predictions. So this involves sub-seasonal from 10 days to up to a month typically. Then for the next months is what we call seasonal, and then even decadal for some years. And in the DST, the range we are looking at would be the first 4 weeks would fall in the sub-seasonal range, and the next 3 months would fall in the seasonal range. At this time scale, as we will see, there are other sources of predictability that come into play as the initial conditions are being lost. And then at the other side of the timeline, we have climate projections, which are the ones used in climate change studies. If we look at this as the system as a series of different components, we have the Earth with the sea ice, with the ocean, the land, and we have the atmosphere. So each one of these components has to be represented in a system which tries to make some predictions. So again, this timeline is similar to the one of the previous slide. So at the beginning, we have the shorter scale. So what we would call the weather forecast, which has very high predictability due to that influence of the initial conditions that are very well known. And then this predictability starts to drop. It is at these time ranges where the sub-seasonal and the seasonal predictions come into place. And there are other sources of predictability, like the land or the sea ice, and the ocean, for example, the sea surface temperatures, that have some influence in the state of the system.
Okay, to understand a little bit more what we are talking about, seasonal and sub-seasonal predictions, we want to introduce here an analogy with this pendulum that you see in the screen. It's a double pendulum. So mainly, the atmosphere is a chaotic system, and that means that from slightly different initial conditions, after some time of simulation, you can end up in very different situations. So what we have here is a very simple chaotic system. Two masses that are attached with a string to a fixed point, and we let them oscillate. And you see that the blue lines are the trajectories of several simulations of this system. And after some time, these trajectories start to diverge, and it's difficult to tell the position of the ball. While at the beginning of the simulation, most of the answers lie in the same place, in the same region. So similarly happens with the atmosphere. With weather forecasts, we want to ask where is the ball, and at the very beginning we can tell the position with a little bit of uncertainty, with accuracy, but as time goes, we cannot be sure of the exact position. And then the climate prediction answer to the question of where is the ball would be not the position of the ball, but the probabilities that the ball is on the right side or on the left side. That's a little bit the analogy with what you will find in the DST, the probabilities of being above or below normal conditions. Okay, then I also want to show you this plot. This plot shows the evolution of Arctic sea ice extent. This is the for 2019, for this current year, is the blue line that you see, while the gray contours or the gray shades show the climatology, so the typical situation in the previous 30 years. And you see that currently we are well below in terms of sea ice extent. You all know that climate change is becoming an emergence now. And we can see that this year is especially important in terms of the amount of sea ice extent that we have. And this is very relevant to the climate, because although the Arctic is very far from our homes, the sea ice in the Arctic reflects a lot of radiation from the sun and reflects it to the space, and it's radiation that we lose. So if we have less sea ice, the Earth will be absorbing more heat in the poles, and that will be heating the North Pole, and all the circulation, all the atmospheric circulation will be impacted by these changes. So this would be a classical boundary condition of the atmosphere, of the chaotic nature of the atmosphere. Even if we cannot tell the exact state of the atmosphere 1 month ahead, we can tell that the very low Arctic sea ice extent that we have now will have an impact on that. And also, this is relevant to understand why seasonal and subseasonal predictions are becoming even more relevant under climate change, because many industrial projects, or even, I mean, the society as a whole, we estimate most of the risks that we face in base of the past observations. For instance, for a wind farm, you would estimate the risk of having a month with very low income based on the last 30 years. But then what happens if next 30 years are not alike the past 30 years? And then we need a better answer, and seasonal and subseasonal predictions will help us with that, hopefully. Okay, then we move on to after this introduction on more general concepts on predictability, and we move a little bit to more concrete aspects of the data and products that we are presenting in the decision support tool. First of all, as Isadora already mentioned, in the left panel of the DST, you can select from a list of essential climate variables. Those are surface parameters that are known to impact the energy system. Wind speed, solar radiation impact renewable generation, temperature, which is known to affect electricity demand, and precipitation, which is very important, of course, for hydropower. And also you can see mean sea level pressure, which is a very useful indicator of the state of the atmosphere as a whole. Then, aside of these surface variables, we are also willing to introduce in the tool energy indicators, so generation and demand indicators. This is not yet available, but will become available soon.
Okay, in terms of systems that are being used within the DST, we have two different systems. For the subseasonal range, we have the National Center for Environmental Prediction CFS version 2. And for a seasonal forecast, we are using ECMWF, which is the European Center for Medium Range Weather Forecast, Seasonal System 5, which is the latest seasonal system. In the case of subseasonal, we'll soon have access to other systems, so because we're part of a pilot project within the S2S project, which will make available real-time forecasts from other systems. And then we're also using reanalysis for bias adjustment and verification purposes, which is ERA 5, also from ECMWF. So I'll go a bit more into detail. So in the case of seasonal predictions, System 5 is an ensemble prediction system. So this means that instead of one single prediction, as in a deterministic system, we have several members to give an indication of the uncertainty. So we have the system is initialized from slightly different conditions, and then we let every member evolve, and then we get an ensemble of solutions for the same forecast, as is shown here in this graph. This type of ensemble is called burst because all the forecasts are initialized at the same time. This system has 51 members and is updated monthly in the DST. And then for subseasonal forecast, we're using NCEP. And in this case, the system is initialized every 6 hours. So every 6 hours, there's a forecast running, which consists of 4 members. So to produce a larger ensemble, we have to aggregate these forecasts and to produce a higher number of members. So in this case, what we are doing is taking forecasts of 3 days. So we have each 6 hours, we have 4 forecasts, and that means 16 members per day, and we're taking 3 days, so we have a total of 48 members in what's called a lagged ensemble. Opposed to the burst ensemble, the initializations have a different start date, but then we aggregate it together to have a single forecast for a target period, which in this case are week 1, 2, 3, and 4. And this system in the DST is updated once a week, which is on the Thursday, and it becomes available on a Friday.
Yeah, another important point about the subseasonal and seasonal predictions that we present in the DST is that we do not aim at predicting the exact conditions one day or one single hour, but what we want to understand is the anomalies of the mean value for a longer period. For the subseasonal predictions, we employ weekly averages, while for seasonal predictions, we employ monthly averages. So what we try to foresee is if the monthly average of one of those variables is above or below normal conditions. And in this timeline, you can see how we compute the first 4 weeks of the subseasonal forecast from the start date. The start date is the date at which the forecasts are initialized with the initial conditions, with the current observed conditions. As Andrea said, the subseasonal predictions are always initialized on Thursdays. Then we make them available at the S2S for DST, typically on Fridays, and then they present information for the weeks starting from next Monday to Sunday and so on. while for the seasonal prediction systems, they are initialized always on the first day of each month, and so they are updated once per month, but they only become available by the 15th of the month. And you will also you will always find information for the next month, the second next month, and the third next month.
Okay, so what are the products that finally appear in the DST? So as we've explained, this is probabilistic information. So we take all the members, which are output from our systems. You can see on the panel on the right, all the yellow dots would be the output of all the members, and then we have a distribution covering all these members. So we take all from the climatology, we calculate the 66 percentile and the 33rd percentile, and we can divide this into terciles. So in red, we'll have the above normal tercile, gray would be the normal tercile, and blue would be below normal conditions. In this case, we are talking about temperature. So to compute these probabilities, we take the members that fall within, for example, the higher tercile, the above normal tercile, and we divide by the total number of members, and that gives us the probability of the temperature being in the above normal tercile temperature. In this case, we proceed the same way for all the variables. Then the 90th percentile and the 10th percentile are also indicated in this graph, and this the members that fall above this threshold or below this threshold are indicating the probabilities of having an extreme value. So you can see in the DST, when the circles appear, the color indicates which one is the most likely tercile. So in this case would be the above normal one. And then the size of the circle, as Isadora explained, indicates how much is that probability. And then the probability of extremes is indicated with a triangle. So when we have a triangle indicated in the DST, this means that there is above 25% probability of having temperature above the 90th percentile of the model's climatology.
Another concept that is very important to produce the forecasts is bias adjustment. All models and prediction systems that we employ, they have biases due to the simplifications that they make in simulating our world. And I like to employ this analogy with an archery shots, and then in this case you can see that all the shots were too low. So if you have a model that is consistently giving too low values, you will want to adjust your telescopic side of your model, and that's what bias adjustment means. Without going into much detail, the bias adjustment methods that we employ in the project, they correct the mean bias, but they also, which is what I'm showing here with this arrow, but we also are correcting the spread of the ensemble, which is a probabilistic concept, which is very important to produce reliable forecasts. Reliable forecasts mean that the probabilities that we are giving in the DST have some sort of connection to the reality, in the sense that the probabilities that you are giving have a connection with the number of times that this event really happens. And when that happens, we say that we have calibrated predictions, or reliable predictions.
Okay, last but not least, of course, the question that everyone will be asking, well, how good are these forecasts? So we, of course, have a verification process, which is when we measure what we call the skill. So skill scores are a relative measure of the quality of the system. We compare them to a basic benchmark, which would be climatology. So if you didn't have any forecast, you would base your forecast in past observations of that month or of that week of the year. To do the verification, we use what's called a hindcast, which are realizations of the same system, but for a set of years in the past. You can see in the figure here, we would have, for example, from 1993 to 2017, the forecast for the same month. And using all that data for which we have a truth or observation from our reanalysis, we can estimate how good that forecast system is for that location and for that time period. It is important to say that because we are talking about probabilistic forecasts, we cannot estimate how good a forecast is just based on one single realization, because we're giving a probability. Therefore, you need a probability of something to happen, but you need a very large sample to be able to define if that probability is well calibrated. So we have specific skill scores for the skill of the tercile probabilities. We have this skill score here. So the skill scores, as they're presented here, are percentages. So because they're compared to a benchmark, which would be climatology, this means that 0 equals our benchmark. And then the higher this percentage is how much of an improvement we gain upon climatology. For the extreme probabilities, we also have a specific skill score, which in this case is Fairbrier skill score, also normalized by climatology.
Okay, so with that, we finished the technical presentation, and Joan Miquel, the floor is yours again.
Thank you, Llorenç and Andrea, for your presentation. Right now, we are going to just hold a few minutes, and we are going to processing some questions, and we are going to answer the Q&A. So the first question we have from Vera is she's questioning what is the period used to calculate the historical average used to calculate the probabilities?
For each system, we have a different period. So in the case of NCEP, the hindcast period is from 1999 to 2018. And in the case of System 5, the hindcast period is from 1993 until 2017.
Okay, thanks. Hope this is answering the question. We have another question from Rory Kelly. Is the forecast window based on the current date or the time from the latest forecast?
Yeah, okay, so this is it's easy to get confused with the dates with such settings. We usually count the forecast times from the start date, so the day that the models were initialized. And it is important not to confuse that with the days we publish the information on the tool.
Okay, thank you. Okay, we have another question from Nour Sob. Can this tool be integrated or expanded into an energy production forecasting tool for renewable energy resources, mainly wind and solar? Yeah, I think Isadora, you can answer this question.
Basically, there is the potential for this. Of course, it is not something that can be easily done. I mean, through the online tool, it is what it is, but through the option of downloading the information, either through the API or other systems, there could be a way of analyzing how it can be integrated. It has specificities. I mean, the way the information is calculated, it gets 6-hourly data, but this 6-hourly data itself, it's not meaningful. So yeah, it requires some technical expertise, analyzing which is the energy model it has to be implemented in and which is the available information. But the potential is there because the information will be able to be downloaded. And if you have already done something with ECMWF, then this could be doing something similar, but with better or improved forecasts because of this bias adjustment and calibration.
Thank you very much. We have another question from Jan Dutton. How do the seasonal and sub-seasonal forecasts perform based on the skill scores?
So typically what we can see that for the shorter lead times, that's for the first weeks, we obviously have more skill than for later ones. But there are also some patterns. For example, in winter, there tends to be more skill than in summer, and also depending on regions. So there are even at longer lead times, there are regions that stand out with higher skill due to some sources of predictability.
Question from Homrani Iba. Is the skill computed once or updated each month, taking into account the skill of previous forecast?
So the skill of this month, for example, would be computed from the years that are included in the hindcast. So not the past information from other months, but next year we would have the possibility to include this year in next year's skill computation.
Okay, from a question from Alejandro Calderon. Is this going to be a commercial product? If yes, when will it be available? Okay, thanks for this question. This is going to be a commercial product. In at least the beta version will stay at least for 1 year, and a little bit more long. But at least in 1.5 years maximum, it will be a commercial product available. So this is why this webinar and other events are important for us to collect feedback from the users and to tune all the final adjustments for being a fully commercial proposal. So that's yes. Right now we are finishing the time, so we will move forward to the wrap up and finalizing the presentation. Okay, so just for the audience information, this has been the first webinar of a series of webinars, and at least 5 more webinars are planned in the program. The next one will be in November. We want also to remind that there's a monthly subseasonal to seasonal outlooks, which is short information. I think Isadora has already mentioned it. It's summarized information about the subseasonal and seasonal outlook, and it's a PDF format. We have also available case studies through the website, and also technical reports too, if you want to, for the ones who want to know more in detail, more technical information. And I think that's all. I don't know if someone wants to add anything else, but this is the final information. Thank you for attending the webinar. Of course, you can ask any question you want through this email information, s2s4e@bsc.es. So we will be really pleased to answer any question you have. Thank you for everything, and bye-bye. Have a nice day.